time, guys, we're going to talk about graphing proportional relationships. We talked about tables with proportional relationships. And in a table, we said that the unit rate remained the same. So we need our unit rate always to remain the same. Let's talk about the coordinate plane first. A set of axes on a flat surface is called the coordinate plane. And it's chopped up into 4 quadrants. The first is always up here, and then it rotates counterclockwise, going 2nd quadrant, 3rd, and 4th. So you want to make sure you label those. Maybe stop the video and put them in your dictionary. But you have the y-axis, the origin, the x-axis, okay? And again, make sure you have the words quadrant and coordinate plane. When I label a point in the coordinate plane, I'm going to start with x. I'm always going to go alphabetically. So the x coordinate always comes first. And then the y coordinate always comes second. X, y, keep it in alphabetical order. And then the point 1, 2, surrounded by parentheses, is an ordered pair. Or you can also call it the coordinates of the point. Okay? So if you look down here where it says graph the points 2, 3, I would start at the origin. I always start at the origin. It's like walking into the front door of a building. I start there first. And I have to walk in a building horizontally before I can get to an elevator to ride it up or down. So the x coordinate always tells me to walk either right or left. So 2 tells me to go to the right 2, and then 3 tells me to go to the 3rd floor. So walk 2 to the right, up 3. And then I would label it with parentheses 2, comma, 3, close parentheses. The point -3, -2 tells me I still walk in the front door. I walk -3 till I go to the left 3. And then down 2, I'm going to take the elevator down 2 floors. And again, I always label my point, and I use the parentheses. Hopefully that makes sense for you. So let's look at proportional relationships when they're in a graph. Okay? So if I was going to make a table to represent the slowest mammal on Earth is a tree sloth. It moves at a speed of 6 feet per minute. Determine whether the number of feet the sloth moves is proportional to the number of minutes it moves by graphing it on the coordinate plane. So if I was going to look at this on a coordinate plane, I have my x values and my y values. Y is always given first in the table, and the x values are given second. Okay? So they actually did this backwards. It should be the other way around. Just so you know, they did this backwards. It should have been the y values on top. So he started out at 0, 0. And then he goes to 1, 2, 3, 4, 5, 6. And I'll give you some graph paper so you can do this yourself. But then I go 1, 6, 2, 12. Is that going to be a proportional relationship? Okay? What is my unit rate? Well, if the 6 had been on top, like it should have been, I would have 6 to 1, 12 to 2. Is 6 to 1 equal to 12 to 2 equal to 18 to 3, and so on? Yes, it is, because they all reduce to the same thing. But what about that 0, 0? Let's see where that comes into play. It made it start at the origin, didn't it? In the origin, if you have a proportional relationship, it will always start at the origin and be a straight line that goes from there. Okay? So this is super important if you want to highlight it. The line passes through the origin and is a straight line, so it is proportional. A straight line passing through the origin is a proportional relationship, okay? So let's try this. James earns $5 an hour for babysitting. Determine whether the amount of money he earns is proportional to the number of hours he babysits. Okay, first of all, think about your graph. X would be the, what is independent? Number of hours that he babysits, right? So that's the 0, 0. What happens when James babysits for 0 hours? He gets $0, okay? And then I have 1 hour, 2 hour, 3 hours, and then videotaping our lesson if you just want to have a seat. So if James is if James works for 1 hour, he gets $5. If James works for 2 hours, he's going to get $10. So is that going to give me the same unit rate every time? Well, $5 per 1 hour, $10 per 2 hours, and so on. Is that going to be a straight line that started at the origin? Yes, because again, it's a line passing through the origin and it's straight. So, yes, because it is a straight line through the origin. Okay? Let's take a look at something that might not be. Okay? The cost of renting video games from Games Incorporated is shown on the table. Determine whether the cost is proportional to the number of games rented by graphing on the coordinate plane. So let's look at a coordinate plane. They've already done it for us down here. But 1 game is $3 and 2 is $5. I can already tell that my unit rate changed because 2 at $5 means I only paid, right, $2.50 a piece, okay? What would be the cost of 0 games? $0, okay? So it would start at the origin because you would have a 0, 0 point, but my unit rate would not remain the same. So no, it's not in proportion. I'll just abbreviate that. Not in proportion because the unit rate changed. You got a better deal when you rented more games. All right? Let's try the got it section on letter B. The table shows the number of calories excuse me, that an athlete burned per minute of exercise. Determine whether the calories burned is proportional to the number of minutes by graphing. So obviously, if you go for 0 minutes, you don't burn any calories. So it's at 0, 0. After 1 minute, I've burned 4 calories. And after 2 minutes, I have burned 8 calories. In 3 minutes, whoops, I shouldn't have made that point. 3 minutes, I burned 13 calories. So is this rate staying in proportion? Well, the numbers are a little odd, so I'm not really sure. Is 13 divided by 3? Because it does appear to be a straight line, but is my rate staying the same? 4 to 1 and 8 to 2 does remain the same, but 13 divided by 3 is not 4. So it is not. You have to check more than just 1 because this one, the first one, does make it appear to be that, but you have to work harder over here. Okay? So now I want you to take a look at example 3 on the next page. Which batting cage represents a proportional relationship between the number of pitches you throw and the cost? Okay, so we have softball plus. I haven't even started throwing yet, and I got to pay a $3 fee just to enter the place. Okay, so so they have a $3 fee to start with. What does that automatically tell me? There's no 0, 0. So can it be a straight line that starts at the origin? No. So softball plus does go in a straight line, but it doesn't start at the origin, so it can't be a proportional relationship. Is the fun center starting at the origin and a straight line? Yes. So the fun center is the one that is the proportional relationship. Okay?